So good afternoon to everybody. I'm very happy to be reunited with you after the long holidays. We had a winter school year, and on the last day of the winter school we touched on the theory of this topic that you see on the board, that side, homeostasis. But today I don't want to necessarily revisit the theory, but I want to prepare you on how to engage with a question paper. I've compiled questions from different years. All the questions you see there in the document you received, and the learners who are viewing this at home, you will have the notes that you can download together with the recorded lesson which we will post tonight on monetlaproject.co.za. All the Saturday school lessons are there for the whole year, mathematics and all the other subjects that we have in this lecture hall. But my main purpose of this discussion today is to teach you on how to engage with a question paper, because I've seen too many learners that know the work 100% and then they score 60% in the exam. Many learners do not properly, it's not only about reading, but they don't engage with the question paper. That means you must reason with yourself, and today we're going to look at some past questions to practice. The most important advice I can give you in your preparation, you can maybe write it down for especially life sciences, is 50% of the time when you prepare, you study the work. The other 50% is you go through past question papers. There are past question papers on our website for all subjects. monetlaproject.co.za, there's past question papers for all subjects for many years. I recommend you focus on the years from 2021 up to 2024, also the supplementary papers. I've taken questions here from years before that because there's some questions that I liked. Do not go beyond 2014 because 2013 was still the old curriculum. The CAPS curriculum came in 2014. But we're going to see how to reason on certain questions. And please, make a note. This is where learners go wrong in life sciences. They think life sciences question papers are difficult. Maybe the work is not the easiest. The work that you study, you must prepare yourself well. But please write it down for yourself. I want you to make a note that life sciences questions in the question papers are always easy. They never ask questions that are over the top, or they never try to trick you in life sciences. I've seen in some subjects some very difficult questions. I've seen it in many subjects. But life sciences, the work itself takes concentration and preparation, but the questions are always easy. If you look on the screen what I've got here at the moment, and we will look at the questions that you've got there. You can open your papers along. It's at the back of this first page that you have. You turn over, and there are the questions that relate to this diagram that you have on the front page. You will see that the questions are always very, very easy. But before we dive into the question paper, past questions of past papers, let's just recap quickly. If you look on the board here, who can raise the hand and tell us, what are we talking about when we talk about homeostasis? What is homeostasis? It's a topic you've done at school or maybe busy doing. I can just tell you while you're thinking about it. For us who are senior markers and chief markers, we found that there's no topic as poorly answered in the exams as homeostasis. The learners somehow don't get it right. I think it's because they don't engage properly with the question paper. So, what is homeostasis? Can somebody please raise their hand? Thank you so much. All right. Now people listen carefully what he says because he is correct. You've answered well. He says, everything in your body must stay constant. If the temperature outside is -5 or 40 degrees outside hot, your body must stay 37. Your body must make a plan because your enzymes in your body, especially the enzymes in the brain, if it's too hot, they denaturate and your brain cannot function. You can have permanent brain damage. If it's too cold again and your body temperature would fall, let's say from 37 to 30, then your enzymes become inactive. Then you also have trouble and you die from hypothermia. So everything must stay the same, your pH. We discussed as part of the matric curriculum, and you can write them down. 5 factors that you need to know. What does the body do to keep these 5 factors constant? That's what he says. He says, I asked the question, what is homeostasis? He says, it's the maintenance of a constant internal environment. What are the 5 factors we need to know for matric? Number 1, temperature. Number 2, carbon dioxide concentration. Carbon dioxide is very poisonous. You must breathe it out all the time. Carbon dioxide concentration. People, what do I mean by the word concentration? In simple English. It's simply how much is in there. If I say your blood, I test your blood, and you've got a high carbon dioxide concentration, it means that you've got a lot of carbon dioxide. If I say you've got a low salt concentration in your blood, it means you've got little salts in your blood. It's just a scientific language. And we can go and talk about concentration scientifically, but I'm not going to go into that. But it simply means high concentration means there's a lot, and low concentration means there's a little. So what are the factors you need to know? Temperature is one, we call it thermoregulation. Carbon dioxide concentration is one. Carbon dioxide is poisonous, it kills you. It must go out, you breathe it out. Number 3, salt concentration. Too much salt in the body, dangerous. You get a stroke and you can die from that due to high blood pressure. Too little salts again, you get cramps. You should not have too much of something or too little. Number 3 is salts. Number 4 is water balances. Please shout out, what is the proper word for water balance? We're going to study osmoregulation, we'll do it again today. Osmoregulation. And then the last one is the one I've got here. The glucose concentration, how much glucose, and we put it in square brackets like that. Those of you doing chemistry or physical sciences, you know we can use square brackets for the word concentration. I can write out the glucose concentration, or I can just say glucose in square brackets. It means how much glucose is in the blood. Now you have big trouble if you do not have 100 milligram of glucose for every 100 mLs of blood. That's exactly what you must have. If you have less than this, let's say you stay at 60, you're going to faint. You're not going to die, but your brain is not going to get enough glucose. Glucose is your petrol here in the blood. Because all the cells of the body take glucose out of the blood, and they need glucose to produce energy. Where does the glucose come from? All food you eat, you can make a note of this, all the food we eat is eventually broken down to glucose. It is absorbed from the digestive system into the blood, and there it goes. If it's too little, you have trouble, you faint. But if it's too high, let's say I've eaten a meal. At this point, I've eaten a meal and my blood is absorbing the glucose from my intestines. And the glucose is now high. 180 milligram for every 100 mLs of blood. Your body will make a plan to bring it back to normal, because I'm telling you, you're busy with homeostasis. Everything must come back to normal. It can't stay up there. If it stays up there, you're suffering from diabetes mellitus. Now you need to know that expression, that word, terminology. Diabetes mellitus, what is it? When you have consistently a blood glucose concentration that's higher than the normal. Let's say it's there. What will be the consequences? I've taught learners young as you that were suffering from diabetes mellitus. What is the consequence? First of all, their eyes are affected. Eventually they turn blind. The next thing, if they have wounds on their legs, it doesn't heal. They get gangrene, and they have to amputate first your toe, then your foot, then your leg. It's a serious condition. And I can go into a whole explanation why it's so serious, but you don't need to know that. All you need to know is it must stay at this level, it must stay normal. If it's there, it's too high. Now I told you, what is homeostasis? Because homeostasis refers to the plans the body is making for those 5 factors. I talk about carbon dioxide concentration, osmoregulation, and so on. But for now, I'm just looking at the one, and that is glucose. We're looking at it because each one has got its own mechanism. We're looking at glucose concentration at the moment. So when I asked, he answered so well. He said, what is homeostasis? It's the maintenance of a constant internal environment. Now, I've seen this question often in the paper. They ask, define homeostasis, 2 marks. Then I would write, like he said correctly, keeping everything constant in the body. But you must add a second thing. And nowadays, what they do with this definition, they give you 0 marks or they give you 2 marks. If you just said the first part, they don't give you 1 out of 2. You must give the whole definition. So please write down, what is homeostasis? It's the maintenance of a constant internal environment despite the changes in the external environment. So also could also refer to the changes in the internal environment. So despite the changes, so the changes, make a slash there. Internal or external environment. There's changes, but your body keeps constant. And that's amazing. When I look at you, I can see you're healthy. It means your body is fighting this battle and it's winning it. Everything in your body is staying constant. Your temperature, if I measure it now, it will be normal where it should be, 37.5 degrees. If I test your glucose, probably it will be 100. If I test your salt balances, probably it's perfect. And that's why you're so healthy, because your body is busy with homeostatic control. So what happens if, people, I'm going to write here, if you've eaten a meal, now high in sugar, even starches, bread and so on, you digest it. Soon after digestion, the glucose, which is the final product of digestion, is absorbed, and now it becomes too high in the blood. The blood goes through an organ that detects the problem. That organ is the pancreas. Now the pancreas has got little groups of cells called islands or islets. Can you remember, shout out, what are these islands called? Inside the pancreas, there's little groups of cells that group together like islands. So we call them small islands, so we call them islets. So a small island is an islet. It's islets of, it's a certain Dutch scientist, I think he was Dutch, Langerhans. He found these, and he said, once something has to detect the problem. If there's a problem, something has to detect the problem. What detects the problem? It's the pancreas. Now a plan has to be made. So what now happens, it releases a hormone from here called insulin. So insulin is released from the pancreas and it goes in the blood. What is insulin? Insulin is a what? It's a hormone. Shout out, what are hormones? They're chemical what? So a messenger gives a message for something that must happen. So what is the message that insulin carries here in the blood? Insulin travels here. And as far as it travels, it gives a message here to these body cells to say, please, there is too much. The glucose in here, the glucose concentration, I'm making G for glucose, is what now? What is the problem? It is what? There's too much glucose in the blood. It's saying to the body cells and ultimately to this organ called the liver, please help. Make a plan because the person is going to die. You die from sugar diabetes if it does not come back to normal. So what is the message? The message is, please take some of this glucose that's in the blood because we are too many here and make it part of the cells of the body. Whether it's muscle cells or other cells, it encourages the absorption of glucose out of the blood. Because now it will be less in the blood, it will come back to normal. Does it make sense? People, everything in your body makes perfect sense. Everything is very, very logic, what's happening inside your body. So if it's now less in the blood, where's all the glucose molecules? They're in the cells, and the cells can use them to produce energy. That's why, can you understand why it makes sense? If somebody does not produce enough insulin, look here, the insulin is not enough. What do you think will be the consequence? Please raise the hand. What will be the consequence for this person? Now you must just take what I've said here and just say the opposite, because he's not producing enough insulin. So what will happen? So just put it in a sentence. All of you know the answer. Remember, we always ask easy questions in life sciences. We said, look here, if it's too high, the messenger insulin must give the message for something to happen. What must happen? The glucose must be encouraged. The scientific word is, it stimulates the absorption of glucose from the blood into the body cells, so that normally it will not be too high anymore, it will come back to normal. But let's say a certain person, a young person like yourself, does not produce enough insulin from his pancreas. What will be the measurement of the glucose in here? It will still be, obviously, because the messenger is not there to give the message. So nothing will happen. Why are you not leaving the classroom now? Because nobody is telling you to leave. If we have a messenger that comes in here and says, you must leave now, there's danger, then you will react to the messenger. But there is no messenger, so you're not leaving. So there is no messenger because the person is not producing insulin. Now, the doctor will do two things. Please raise the hand, use your own logical thinking, and tell me, and tell the rest of us, why will the doctor say something like, you're a young person, you are sugar diabetic, you are not producing enough insulin, I want you to play a sport. I want you to be physically very active. You test your blood, because they test their blood all the time, they've got monitors with them, and you find your glucose is too high, then you do exercise. You run on the spot, or you do some push-ups, or sit-ups, whatever you want to do. Please raise the hand. Why is the doctor giving good advice? Thank you so much. So that your cells will now, without the messenger is not there. Now I'm running at the spot. Now the cells say, give me some of that glucose, I need to produce energy. Because the guy's running. I need to produce energy for power. So then the cells will take automatically, and the glucose go down. Do you see? Other people, they drive in a car. They test their blood. They say, oh my goodness, the glucose levels are too high because I know I don't produce insulin, I'm sugar diabetic. Then he has with him a tablet that he got from the pharmacy that he drinks containing the messenger. We can make this in the lab. So your body produces, I know most of you are not sugar diabetic. You don't suffer from diabetes mellitus because your body naturally produces insulin. So the messenger is there to tell the cells to take glucose here from the blood. But if you don't have the messenger and you can't do exercise, then you must drink a tablet. If it's even worse, you must inject yourself. And many of them inject here around the stomach, around the belly button. They inject, and every day they have to inject insulin, which they buy from the pharmacy. But fortunately, your body is producing it naturally. You see, you've got reason to be grateful. All right. But now, there's a key organ. It's a target organ. Target organ is the liver in this whole metabolism of bringing the glucose back to normal. The liver weighs 1 kg. And for those of you who are going to study medicine next year, you will study the 1,000 functions of the liver. The liver's got 1,000 functions. It's just a small part of the work that you will do. I had students here last year. They are now studying medicine. And they're telling me it's a lot of work. Your liver is a vital organ. People who suffer from liver cancer are really challenged with their health. And it could be fatal if you have a problem with your liver. It's got 1,000 functions. But one of the functions, I just want to focus on one function of the liver. This insulin that comes here, it comes as a messenger here into the liver. The insulin comes with the blood as well. Insulin. It basically tells the liver, please help. It tells the liver, this person has got what? What's the problem with this person? Please say together. What's the problem? What problem is this person experiencing at this moment? Look here, I wrote here, too high glucose concentration in the blood. There's a problem. Insulin arrives here at the liver, telling, please help. The liver says, I'm ready because it's my job. I will take the glucose that's in the blood. I will take that glucose that's here in the blood, and I will pack it away in the storeroom here inside the liver. And I will store the glucose as glycogen. And take note, it's with a Y here. Glycogen. People, if I've got too many papers here on my desk, papers are piling up and becoming annoying. But I still want to use these papers maybe next week. Then I can put them in files and store them that side. When I need them, I'll take them out again. So if the glucose is too much in the blood, insulin, the messenger, stimulates, that's the way we speak. Don't use the word tell. It stimulates. Stimulates means cause. Insulin stimulates the liver to change glucose into glycogen and then store it until it's necessary for the body to need that extra glucose again. But when the blood comes out of the liver here, and there the blood goes to the body, the rest of the body, what has happened now? The glucose levels are back to normal. 100 milligram of glucose now, because the body has made two plans. It encouraged the cells to take the glucose out of the blood and encouraged the liver to store the extra glucose as what? Please say together. With a Y, glycogen. So what is this other word that we use? And we spoke about it at the winter school. What is this word that we use? Do not. Please write there. Do not confuse. Can you quickly write it down? Do not confuse glucagon. So A, yeah. Glucagon with glycogen. What is glycogen? Can somebody quickly raise their hand? What is glycogen? What is glycogen? It is glucose that is stored in the liver. I think that's what you wanted to say. That is glycogen. But what is glucagon? Can I ask this learner here? Do you know what glucagon is? What is glucagon? Glucagon is the opposite. Is the opposite of what? What did insulin do? Insulin caused the blood glucose levels when they were too high to drop, to come back to normal. Am I right? So what happens now? Let's say last night you ate a meal and you had a good meal, starches and some proteins, everything was changed to glucose. Now your body, when you went to bed, had too much glucose in the blood. So which hormone would be released last night? And where is that extra glucose that you had last night from the meal? Where is it stored, in which organ? Now, this morning you were late to come here to campus. You did not eat, you drank water and you ran. You came here and unfortunately they announced this morning that cafeteria will only be open next week. So you did not eat here. So now you get to 1 o'clock today and you feel, how do you feel? You feel tired because the glucose in your blood is only 60 milligrams. It's too low, you have no energy because glucose is your petrol. Now the body says, there's a problem here. And the pancreas this time will not release insulin, it will now release the opposite, glucagon. It travels here in the blood, that glucagon, with the opposite message. And it says to the liver, please release back the stored glycogen back to glucose so that it can come back to normal again because it's now too low. Do you see? It's too low. Please write down there, negative feedback. Negative feedback means when two hormones work opposite to one another. The one increases something and the other one decreases something. This is insulin and glucagon. Right, can you tell us what is glucagon in comparison to glycogen? Please listen to his answer.
Glucagon is the hormone that increases glucose in the blood.
So would you say glucagon is opposite to insulin?
Yeah.
And what is glycogen then?
Glycogen is glucose stored.
Yes. So the one is a hormone, opposite to insulin, glucagon, and glycogen is glucose that's stored. You answered well. Please, people, do not make that mistake that many South African learners make at the end of the year by using these words just the way they want. I can't call Thabo Mathabo. It's two different people. You can't call glycogen glucagon. It's two different things. Are you with me? All right. So now, how do you think, what is the message of glucagon? People, please, I told you, in life sciences you must think in terms of opposites. If the person is running, is using a lot of energy. If the person is not, if he's stationary, then he's not using a lot of energy. You must always think in terms of opposites. So here's my question to you. What do you think is the message of glucagon in terms of these body cells all over? Remember, these are the cells of the body. Yeah, all these are the cells of the body. Remember the message of insulin? So now think opposite. I want you to raise your hand and share with all the friends, and maybe I must spot to one person, because you can give the answer. People, you must learn to think. We can't just be passengers and wait for others to give an answer. Are you ready to give this answer? Let me ask the question, because you should be. What will glucagon stimulate? Or you can use the opposite word, inhibit. Inhibit means the opposite of stimulate. What will, because I told you all about insulin. I told you, look at my arrows here. Look at what I showed you, what insulin does. Look here. This is all under the control of insulin. What I've shown here, inside here, it's all under the control of insulin. And also what I've shown here, it's all under the control of insulin. So what then does the opposite hormone do? Glucagon. Thank you so much.
So doesn't that glucagon change the glycogen back into?
Do you see, she did not have to study this. She listened what I said, and I said, change everything just to opposites. Because glucagon is the opposite of insulin. So she says now, sir, now go for the opposite. What will glucagon stimulate? It will stimulate the conversion of glycogen back to glucose. Because it's too low, it must come back to normal again, pushing out more glucose into the blood. What about the body cells? Remember, in the blood, you have a situation now that's not too high, it's the opposite now. It's too low. Instead of 100, it's now 60 here. As the blood comes past here, what do you think must be the messenger's message to the body cells? What do you think must the message be? Just think in terms of opposites, people. All right, think back. Let's go back to insulin. Who can raise the hand and tell us about insulin? What's the function of insulin here? Look at my arrows. Anybody would like to try? Insulin stimulates the liver, yes, but let's focus on the body cells, because insulin also stimulates something here. What does it stimulate here at the cells? I hear some of you are speaking correctly. Would like to raise the hand? Yes? Of? From the blood. So he speaks correctly. He says, what insulin does normally, look at my arrow. Insulin stimulates greater absorption of glucose from the blood because it was too high in the blood. So it says, take please, help, take. There's too much. Are we together? So now, if he made that statement correctly, now turn it to opposite for glucagon. What is the opposite message? Thank you so much, Butle. All right, now the cells don't store glucose, the liver stores glucose. But what will it do with regards to the cells? It will now not stimulate. What's the opposite of stimulate? Well done. Always use that word. Inhibit. So what will glucagon do? It will inhibit the body cells to absorb glucose, because already there's not enough glucose in the blood. So now it will inhibit it. People, are we together? Now let's interact, and that was the most important part of today, is to talk about how to interact with a question paper such as this question you see in the notes I've given you, and it's also attached for the learners on the website. People, please write down that questions with regards to homeostasis can be asked in 3 different ways. The one is diagrams such as this. Please write down the way homeostasis is asked. And I'm talking about these 5 factors. Today I'm just touching on the glucose. Next week I will touch on osmoregulation and the salt control. And then we'll talk about thermoregulation as well, and carbon dioxide. But for each of these factors, it could be asked, please write number 1, diagrams will be given like this, and then questions are asked from the diagram. Number 2, paragraph questions, 6 to 8 marks. Now, please write down there about the paragraph question. Whenever you get any paragraph question with regards to homeostatic control, whether it's sugar balances or water balances, doesn't matter, or salt balances, you use a framework which I gave to the learners in the valuable notes at the winter school. If you did not get those notes, you must please ask somebody at school who's got them, so that you can also copy those notes for yourself. The winter school booklet I gave. And there on page number 47, I indicated that when you get a paragraph question on these factors, you must answer it on a framework of 6 points. Number 1, what is the problem? You write down. Like in this case, the sugar concentration is too high. You must identify what is the problem. Number 2, what detects the problem? In this case, it was the pancreas that detected the problem. Number 3, where is the control center? So for every factor, there's a control center. In this case, it happens to be the pancreas. Number 4, how is the imbalance corrected? So in your paragraph question, you answer each of these 6 points that I'm giving you. You use this framework for all the factors. How is the imbalance corrected? Number 5, name the hormone involved. And number 6, what does the hormone do to correct the imbalance? Then you describe what is the message really of the hormone to correct the imbalance. Right, another way, so now the third way they can ask it. The first way is they give a diagram like this and they ask questions. Second way is a paragraph question. Let's say, describe what happens after a meal rich in starches and the food is digested to glucose. Glucose levels are too high. Describe the homeostatic control to bring it back to normal, 6 marks. Then you follow this framework. The third way they like to ask homeostatic questions are graphs. Please write there, graphs. And please, people, graphs are always easy. A graph is nothing but a picture. And any picture speaks 1,000 words. It's a story. So please, people, never ever be intimidated by graphs. You'll see today, I'll teach you how easy it is to read graphs. But let's look at this question that you have here in front of you. You've turned to the back page where the questions are. Can you shout out the answer? The first question asks about what you see on the board there. What is organ number 1? Shout out the answer. Do you see, if you were Matric 2018, you would have scored a mark. Do you see how easy the questions are? People, please, when you enter the exam room end of the year, always remember what I said. Tell yourself, there's never a trick question in life sciences. All questions are logical and easy. Look here. And now the next question. What is the hormone 2? Look there. You read the diagram there, and if I show here on the screen, you see here, here's the problem where I'm indicating there with the blue, that the levels of glucose are too high. Then the pancreas detects the problem and releases a hormone. What did you say is that hormone? Insulin. So there we have it. Then insulin stimulates which organ? The liver. Now look at 1.5.3 in your question paper. What is the hormone number 3? Now number 3 refers to this scenario here at the bottom. The opposite problem. The opposite problem is now the glucose levels are too low. So what is that hormone which I told you is the opposite of insulin? Glucagon. Should I not have written glycogen? No, it's glucagon. So do you see you're scoring marks here at 1.5.3 as well. Now what is 1.5.4? The disorder caused when organ 1 fails to release enough insulin. What do you call that medical condition? Let me just write it here, you need to know it. Diabetes mellitus. So now, what do you call the last question there for 5 marks? The last question, the mechanism that controls the levels of glucose in the body. What would you say? Shout out the answer. If you were matric that year, what would you have written at 1.5.5? What would you write? It is involved, negative feedback is involved, but the answer is homeostasis. Everything that keeps everything stable inside the body is, say together, everything that keeps everything stable is homeostasis. All right, so there we have it. Now, let's go to another question which I saw in 2018. Here it is. You also have it there on that same page where we were now. So now we need to read and ask ourselves, what is this question all about? So remember, this was 3.3 in that year. And did you know, all right, let me first read here and then we'll talk about it, because this is what really happens. Let's read the question. Now, here's my advice to you. Some learners just sit in the exam room and they read and it's just words and so on. Not you. Some schools allow a highlighter in the exam room. If you have a highlighter, you can use it, but not in your answer book. But some schools will say no highlighters, that's okay. Then you just circle the words, the key words. What will we circle? Let's have a look. It says here, the graphs below show the effects of eating many small meals and eating fewer large meals. Do you see what the graphs are all about? Even read the heading there. The one graph I'm going to circle here, the effects of eating many small meals in comparison to eating fewer large meals on blood glucose. So they're comparing. What is the benefit for somebody suffering from sugar diabetes if they can eat, look at the question, many small meals in comparison to fewer large meals? Now they say, in the second sentence here, where my pen is there, the arrows of the graph indicate what? What do you read there? Please check on the question. The arrows on the graph below indicate what? And then they say the normal of the glucose is indicated there with that gray line that goes across in both the graphs. People, can you see that gray line there in the middle? It is at what milligrams? Per deciliter. Now a deciliter, don't worry, is 100 mLs. Doesn't matter. But the point is, it's there indicated. So now, something interesting, we're comparing the two graphs here. Can you see this person eating many meals? Look there in comparison to the lower graph. Can you see the person there at the top had more meals than the person at the bottom? But the person at the bottom, they tell us the meals were bigger. He had a bigger plate of food. Now it's real that doctors recommend that if you suffer from sugar diabetes, that you don't eat 3 meals a day like this person here at the bottom. That you rather eat, let's say, 6 meals a day, but smaller. Now we're going to see the logic of that now by looking at this question. So people, this is my point I'm making today. You study the work, but in the exam, September and November, they always will describe a scenario that you've never heard of or you've never seen in a past question paper. Now you must do what I did, circle key words. So what are we comparing here? Is it clear in your minds? Look at my pink that I've circled here. What are we comparing? You see? Can you see when the meals are taken? Look at the first of the person who's eating small meals. When did the person have the first meal? People, can you look at your papers? You can look at your papers in front of you. You see that question called 3.3, or you can look on the board. The person who had more smaller meals and a greater number of meals, when was his or her first meal of the day? People, I find, unfortunately, that you are lazy to think. This is why you're not going to get the results that you deserve. If you study your work 100%, you are not going to get 80%. You're going to get maybe 50%. Because I see you are lazy to engage in the paper. Please, you don't do it now for me. I want you to use your thinking when I ask questions. I'm trying to develop this skill of practicing to think. And it's very easy. These questions are not difficult. You must just open your eyes. The answer is in front of you, or there on the big screen. When did the person who had smaller meals eat her first meal? Yeah, you see, here's 6 o'clock, people, if you look there. There's 6 o'clock, there's 8 o'clock. So between 6 and 7, between 6 and 8, it's more or less the arrow shows run about 7 o'clock. Could be quarter to 7, but let's not debate about that. It's close to 7 o'clock. Right. The person who had large meals had his or her first meal when? All right. Now shout out, please. I'm going to ask a number of questions. Let's focus on the lower graph because it's similar to the top graph in terms of what happens here. So please, I'm going to ask questions and you answer together as a group. By 7 o'clock, let's say 6:30 in the morning, the person that here, the lower graph, the blood glucose levels were below normal or above normal. Let's just get it again. Look at the big screen or look at your paper. I'm going to ask again. The person who had the large meals at 6:30 in the morning, the blood glucose according to this solid line, remember the solid line says here it's the glucose, and the dotted line shows the hormone that's released, shown here in the blood called insulin. It was below normal at 6:30, am I right? All right. Then the person ate here just before 8 o'clock, this one with the large meals. You can see here the person ate just before 8 o'clock. Then what happened to his blood glucose levels? What is the trend you see there? Did it go perfectly to normal? It went where? Above normal, which means now it became hyperglycemic, which means too high. Person now has, please, write down, always look at the peaks and the low points. Always look at the peaks and the low points on a graph. Look at that peak. Now read there. At that time after the meal and the food was digested and absorbed, where's the blood glucose levels now? You tell me the value. It's about 160, or maybe you can say, often in the exams they will make it more clear, but in this case it was around about 160 or 165 milligram. It's too high. So now according to that graph, which hormone is now released? Can you see it in the graph? How do you spot in the graph that insulin was released by this person's pancreas? How do you spot in the graph that insulin was released? Can you see the insulin concentration from 8 o'clock when the person ate and the glucose went to this high level that I'm indicating here? That the body detected the problem. So what had to be released by the pancreas? Which hormone? Does the graph show you that? Now insulin gives its message. Why do you think there at just before 10, the glucose at the high point starts to come down again? Look here at the graph. It's coming down, back to normal. What caused the normality? It's the messenger insulin. Now, don't you think insulin in your body should have continued? Maybe I can make it here with a different color. If the insulin here at just before 10 reached a high point as well, Now, insulin, look there at my dots I'm making there, that it increased there. Would that be okay? Does it make sense that it would come down here? Please raise your hand and say, why does it make sense that it actually comes down here? Look here, the line shows it comes down here, the insulin concentration in the blood. That means the amount of insulin, the pancreas is releasing less of it. Why does it make sense in simple English? Because? So the problem has been solved. Once a message has been given and the response is there, doesn't make sense for a messenger to keep on giving the same message over and over. So once insulin is given the message and the problem is solved, you can clearly see here the problem is being solved. Look, it's coming down. Back to what? Back to normal. Then the insulin levels can also come down. But now what happens here? The blood glucose is too what when I'm making the blue there? The blood glucose is too what? Too low. Now what must happen? The person must now eat. There is eating. Now it goes to normal, but it even goes beyond normal. Now quickly talk to your friend and look at this question that's often given. In many years they give this question. Here's the question. Please write down the question here on that page where I've given you the question paper. Here's the question. It was not asked in this particular year, but they like to ask it. So refer to the lower graph where the person is eating larger meals. And then the question is, from the graph, calculate the time from 6 o'clock till 8 o'clock at night where the person experienced higher than normal blood glucose concentration. So calculate the amount of time the person experienced higher than normal blood glucose concentration in this time period from 6 o'clock in the morning till 8 o'clock at night. Quickly turn to your friend and say, how will you calculate that? You got the question. All right, let me help you there, people. So it becomes very easy. You just look at the big screen, people. So when is the glucose concentration above normal? So we find that line, the normal line, which is going across. It's indicated there in gray. There you see it. So when is the graph for the glucose above the line? It's from there to there. And it's from there to there in that time period. And it's from there to there. I can even indicate it there in pink. People, do you see it's that time period? Now we read down to the time at the bottom. It's straight down there, and it's straight down there. It's straight down there, and it's straight down. So I'm just going to add up the minutes now. So this time from here, what is it? If you read there, isn't it about 9 o'clock? To about 10 o'clock. What is the time there if you look carefully? Let me just put it a bit higher for you. What is that time? Not quite 9, it's about 8:15, isn't it? To about 10. So people, you just read the time off there. Is it about 10:15 there? And there's about 8 o'clock. People, let's say the graph would indicate it more clearly. Let's say it was 8:15 until 8:15. Then you say, well, here it was 2 hours, eh? If you want to make it minutes, it's 120 minutes. Right, then you add here. Then you go, look, what was that time? Up to that time, how many minutes? Then you plus that. And you take that time to that time. That was the total time when the graph was above the normal. I think it's clear to all of you. All right. the question they asked, now people, I did not include the questions. I thought, let me give it to you now here in class. That here, the questions they asked, please write down. Tabulate 4 differences between the 2 graphs. Now, the answers are on the question paper. And please, this is another bit of advice I want to give you for the exams, is that many of the answers are right there in front of you. It's in the question paper. So now, you've never seen anything like this, and here they suddenly ask in that here, make a table, where you draw a table, this side you write more smaller meals, and that side you write fewer large meals. And now they say, draw a table and compare. 4 differences. Where will you find the answers? Look there. Who can spot the difference? Please raise the hand. Who can spot the difference? From looking, what you now need is no knowledge. What you now need is good eyesight. You need to spot it, even in the question paper there in front of you. If you can't see on the big screen. Who can spot a difference? There's one. Thank you so much.
So just from looking at the 2 graphs, I can spot already 2. So from the many small meals, the insulin is released quicker than compared to the fewer large meals, and also more insulin was released with the fewer large meals than the many small meals.
All right. Thank you. You've answered well. People is using, is just looking there. And that's what the ability I want to teach you today that you're going to need in September and November. Knowledge is one thing, but you need to engage with the question paper. The question paper must talk to you because it's packed with what? Answers. People, the question paper, the thicker it is, the more you must celebrate. Because there's more information in that question paper that's thick. It's answers packed in there for you. So what did he say? He says, look here. Look at this point here. Here, for the smaller meals, the highest points of the glucose with the smaller meals is 140. Do you see that? But the person who has larger meals, the peak, always look at the peaks, goes up here nearly to 180 milligrams. Do you see now why the doctors tell people in your family that if you become sugar diabetic, eat more smaller meals? Because now you don't need much what? Look what I'm highlighting there. You don't need much. Because look there, the insulin also is not much required. The insulin, that's what he said as well, goes only up to 120. While here, the insulin goes high. It's 160 milligrams. You need more insulin. But I'm sugar diabetic, I don't have insulin. Then rather eat smaller meals, but more of them. Then you don't need, look at the graph, you don't need much insulin. You see, the graph tells you a story. Now, look at the low points. Now, you don't want a sugar low, hypoglycemia, when you suddenly have to urgently get something sweet to eat. But if you have many small meals, look how low does the glucose go. Do you see here it comes the low point at about 60, isn't it? Look here at 60. But the person who has large meals, it comes down here to about 40. Now you understand what happens to you after break at school. You're hungry. It's break, let's say 11:30. And you're hungry and you eat a lot. Now you go back to class. And within 20 minutes in that period after break, you feel tired. You feel sleepy. Why? Because the large meal caused you to release a lot of insulin to stimulate the absorption of the glucose. So the insulin in overproduction is causing too much glucose to be absorbed, and now you fall to very low. You fall to a very low glucose because you had too much glucose just in break time before the period after break. You see, then your glucose becomes low again. Do you see? So that was another question that year when they gave this graph. They asked, please write down there, what is the value of eating more smaller meals for a person who suffers from sugar diabetes? Now, people, I just want to show you what we will be doing here next week. we will be looking at this question, which came from 2019, as far as I remember. It's all about what happens in the kidneys. It's all about ADH and osmoregulation and salt balances. Now, what we will discuss in detail, I found, is a big need among matrics. It's about what I've got here, people. What I've got here, the nephron, is what we will discuss next week, because you did it in grade 11 and you need that background information. So people, I'm looking forward to seeing you next week. Bring the same notes again, okay? Thank you.